So before starting the dropout, I want to explain a very important layer that is related to the dropout. And this concept is the bagging. Bagging is an ensample method. Ensampling, I think you will study in the next part of the course, is basically an averaging for some predictions of some learners. So you have a group of learners and you want to average or collect their predictions in some way. The way that's used in the bagging is the averaging method. So what is the special things about the bagging? First, the predictions or the learners are independent. So they are trained in parallel and they don't take feedback from each other. And the second thing is like the bagging, the learners in the bagging has high variance. They have high variance. So the target of the bagging is to lower their variance. Why? Basically to get less overfitting and to get better generalization. How this is done in the bagging? What's the theory behind it? Look at these equations. Imagine you had the predictions of each learner of in the bagging. In the bagging, basically in sample is random variable, and all of them are independent and the identically distributed random variables with variance sigma squared. So the variance of their mean will be something like this: variance of 1 over n, summation for xi. Xi is the predictions for learner I. Then we take out the constant of the variance with squared. This is something very relevant to the statistic course. So it will be 1 over n squared variance of summations of xi. As xi, all the xi's are independent, so we can get the variance inside. So we say the variance of the summations equal the summation of the variance of xi's. So the variance of xi is sigma squared. Sigma squared is a constant with summation for all n learners. So this will end up with 1 over n squared multiplied by n multiplied by sigma squared. And this is sigma squared over n. So the variance of the mean is less, which means less overfitting, which means better generalization. There is more about bagging if you want to know, which is, for example, like the bootstrapping step before the training of the learners. But this is out of the scope of this lecture, but it's really recommended to be read after the lecture. So what is dropout? Dropout is basically approximation for the process of bagging. So instead of learners, you have all the subnetworks of the network. What I mean by subnetwork? Subnetwork is the result of removing or zeroing or turning off some neurons in the network randomly. So basically, you have a whole network. You turn off random nodes in it with the probability of p. So you turn off or you remove a node with probability p, and you keep it with a probability 1 minus p. And you stop its forward propagation to the next layers. So basically, this drives the rest of the nodes to form a subnetwork which is sufficient to produce good predictions by the backpropagation training. This is an example of a Bayes network. So if we remove like random nodes, you will get all of these possible subnetworks. Here, for example, like we didn't remove any. Here we removed x1, here we removed x2, and so on. This that we called subnetworks. All the subnetworks resulted from removing random nodes from the network. And theoretically, when they are trained, each of them on some many batches, they should be sufficient to produce good results and good predictions. Here, there is some subnetworks that has basically no path between the input and the output. For example, here, and here, and here also, and here. And basically, this problem will become very insignificant when you have hundreds of neurons per layer, and when you have a large dimension input. So basically, the probability to drop all the paths between the input and the output become very, very small. and this problem become very insignificant. This image is taken from section 7.12 in the deep learning book, and it's very recommended to be read. Some notes about the dropout. So dropout is basically, as I said, is a type of regularization method. Regularization is basically operation or some process that's done during the training or before the training to reduce the overfitting of the model. What I mean by reducing overfitting is reducing the variance, reducing the capacity or reducing the complexity of the model. When you have a very, very big model, or you have a small amount of training data, while the capacity of the model is bigger than this, or you have a too long training, you could use the dropout. When you apply training, we use the dropout in this phase, in the training phase. We don't use it in the testing or in the prediction. So when you deploy your model, you don't use the dropout, as you want the model full power with no dropouts, with no neurons removed. Only dropout so that we reduce the variance during the training. That's it. After the training, there is no dropout. And this is by default in Keras, but you need to do it manually in PyTorch with model.eval. Dropout is commonly used basically after the dense layers or the fully connected layers, but it's rarely used in the convolution after the convolution layers. And when it's done, it has very low dropping probability. The dropping probability is very low. Usually the dropping probability is like B is 0.5 or lower. The researchers basically suggest values between 0.2 and 0.5. So let's see how we can add this dropout in Keras in the basic model that we just built. First, let's import the dropout layer here. And then let's add it after the dense layers. Here in the parameters, you specify the dropping probability. Output 0.2. We'll add another one here. For sure, you don't add it after the output layer. That's it. So that's it with the dropout.